In this video, we're going to go over limiting reactants, excess reactants, how to find out how much excess reactant is left over, how to calculate the theoretical yield, and the percent yield. So let's begin. 2 moles of propane reacts with 8 moles of oxygen gas in a combustion reaction. How many moles of carbon dioxide are formed? So what's the first thing that we need to do here? The first thing that you should do is write a balanced reaction. Propane is C3H8. Oxygen gas is O2, it's diatomic. Carbon dioxide is CO2. And for any combustion reaction, water is always a product. Now, before we can do any sort of calculations, we need to balance this equation. Whenever you're balancing a combustion reaction, balance the carbon atoms first, and then the hydrogens, and save the oxygen atoms for last. So notice that we have 3 carbon atoms on the left side. So we need to put a 3 in front of CO2. Notice that we have 8 hydrogen atoms on the left, but 2 on the right. 8 divided by 2 is 4. So we need to put a 4 in front of H2O. Now, how many oxygen atoms do we have in total on the right side? 3 times 2 is 6, so we have 6 oxygen atoms from the 3 CO2 molecules. And the subscript here is 1. If you don't see a number, 4 times 1 is 4. So we have 4 oxygen atoms from the 4 water molecules, so we have a total of 10. 10 divided by this 2 is 5. So we need to put a 5 in front of O2. And so the reaction is now balanced. So we have 2 moles of propane and 8 moles of oxygen. Which one is the limiting reactant? Is it propane or oxygen? The limiting reactant is the one that runs out first. To find it, if you have the moles of both reactants, one method in which you can use is simply divide the moles by their respective coefficient. It's not going to be always the one with the lower moles. It's the one with the lowest mole per coefficient ratio. So for propane, divided by 1. For oxygen, divided by 5. 2 divided by 1 is 2. 8 divided by 5 is 1.6. Therefore, O2 is the limiting reactant. Propane is the excess reactant. Another way in which you can identify the limiting and the excess reactant is to calculate the theoretical yield, or the amount of product that can be formed in a reaction. The theoretical yield is the maximum, the absolute maximum amount you can get in a reaction. So to answer the first part of the question, we need to find how many moles of carbon dioxide are formed. That's basically asking for the theoretical yield, which can be in moles or grams. But for this problem, we're going to do everything in moles. So one way you can identify the limiting reactant is you can take the moles of each reactant and calculate the theoretical yield. The one that gives you a lower value, that's the limiting reactant. The one that gives you the higher value is the excess reactant. So let's start with 2 moles of propane. And let's convert it to moles of CO2. Whenever you want to convert from one substance to another using a balanced reaction, you need to find the molar ratio. The molar ratio between propane and CO2 is 1 to 3. Now, notice that we have C3H8 on the top. So we got to put C3H8 on the bottom and CO2 on top. So according to the molar ratio, for every 1 mole of propane that reacts, 3 moles of CO2 are produced. So these units cancel, and we're left with moles of CO2. Since we have a 2 and 3 on top, we need to multiply 2 and 3. If you have a number on the bottom, you got to divide. 2 times 3 is 6. So what this means is that if all of the 2 moles of propane reacts, 6 moles of CO2 can be formed. That's the maximum amount of carbon dioxide that can be produced from 2 moles of propane. So now let's see how many moles of propane we can get if all of the 8 moles of oxygen gas reacts. Let's start with 8 moles of O2 over 1, and let's use the molar ratio to convert it to CO2. So the molar ratio this time, it's 5 to 3. So for every 5 moles of O2 that reacts, 3 moles of CO2 are produced. So these units cancel. 8 divided by 5 is 1.6. 1.6 times 3 is 4.8. 16 times 3 is 48, so 1.6 times 3 is 4.8. So if all of the oxygen molecules react, we can get at most 4.8 moles of CO2. So in this reaction, when we mix propane and O2, the amount of CO2 that we're going to get is the smaller of these two numbers. So the actual theoretical yield is 4.8 moles of CO2. So that's the answer to the first question. Now the reactant that gave us this answer, which is O2, that is the limiting reactant. The excess reactant will give you a larger theoretical yield, which is not the correct answer. So O2 is the limiting reactant, propane is the excess reactant, and the theoretical yield of CO2 in moles is 4.8. Now let's say if we did the experiment and we only measure 4.5 moles of CO2. What is the percent yield of this reaction? The percent yield is equal to the actual amount divided by the theoretical yield times 100%. So the actual amount, or the actual yield, the amount that we actually got in the experiment is 4.5 moles. The maximum amount, or the theoretical yield, that we can possibly achieve is 4.8. That's the most that we can get. So if you multiply that ratio by 100%, you're going to get the percent yield. So if you type it in, you should get about 93.75%. That's the percent yield for the reaction. Now, if that's the percent yield, what is the percent error? To find it, it's going to be 100 minus 93.75. So the percent error is 6.25%. Now, how can we answer the second part of the question? How much of the excess reactant is left over? How would you figure it out? Feel free to try it. Here's the main idea of what you want to do. The amount of excess reactant that is left over after the reaction is going to be the total amount of excess reactant that we had to begin with. That's the 2 moles of propane minus the amount that actually reacts, or the amount that actually participates in the reaction, and that's going to equal the amount that's left over. So for example, let's say if we have 10 moles of excess reactant, but only 7 moles react. Therefore, 3 is left over. 10 minus 7 is 3. And so that's the main idea of what we need to do to find out how much is left over. So we already have the total. In this case, the total is 2 moles of propane. We need to find out how much reacts. And we can do that using stoichiometry. So let's see how much reacts with the 8 moles of oxygen. So what you want to do is start with the limiting reactant and convert it to the excess reactant. So the limiting reactant is the 8 moles of O2, and let's convert it to the moles of propane. The molar ratio between propane and O2, it's 1 to 5. So for every 5 moles of O2 that reacts, 1 mole of propane reacts with it. So 8 divided by 5 is 1.6. So this number represents the amount of propane that actually reacts or participates in the reaction. That's how much propane is consumed in the reaction. So the amount that's left over is the total minus the amount that reacts. So 2 minus 1.6 is 0.4. So that's how you can calculate the amount of excess reactant that is left over. Let's try this one. 50 grams of benzene is placed in a container with 160 grams of oxygen gas. After the reaction, 30 grams of water were collected. What is the percent yield? How much excess reactant was left over after the reaction? So the first thing that we need to do is write a balanced reaction. So we have another combustion reaction. So benzene plus oxygen gas is going to produce water and carbon dioxide. Now, whenever you want to balance a combustion reaction, remember, balance the carbon atoms first, then the hydrogen atoms, and save the oxygen atoms for last. So we have 6 carbon atoms on the left side. What number do we need to put in front of CO2? So we need a 6, and we have 6 hydrogens on the left side. So 6 divided by 2 is 3. Now notice that we have an odd number of oxygen atoms on the right side. We have 3 from the 3H2O molecules and 12 from the 6 CO2 molecules, since 6 times 2 is 12. So if we balance it now, 15 divided by 2 is a fraction. It's going to be 15 over 2. So to avoid the fraction, let's double everything. So instead of this being a 1, let's make it 2. So we have 12 carbons on the left side. So we now need a 12 in front of CO2. We also have 12 hydrogens. So we need a 6 in front of H2O. So at this point, we have a total of 30 oxygen atoms. 30 divided by 2 is 15. And so we could put the 15 in front of O2. So now the reaction is balanced. Now the first thing that we need to do is find the percent yield. So we need the actual yield and the theoretical yield. We can calculate the theoretical yield, but typically the actual yield is usually given in a problem. Now there's 3 numbers that we have, the 50, the 160, and the 30. Which one is the actual yield? The actual yield is associated with the product. Benzene is a reactant. O2 is a reactant. So water is a product. So the 30 grams of water represents the actual yield. So we'll use that later. But let's find the theoretical yield of the same substance, water. Now, since we have the information for both reactants, we don't know which one is limited or which one is excess. There was 2 ways in which we could figure this out. We're going to use the second method, in which we're going to calculate the grams of water that can be formed from each reactant, and whichever gives us the lower number, that's going to be the theoretical yield, and the reactant that gave us that number is the limiting reactant. So let's start with benzene. Let's see how many grams of water can be produced if all of the 50 grams of benzene reacts. So let's start with 50 grams of C6H6. So what is the molar mass of C6H6? So we have 6 carbon atoms times the atomic mass of 12 plus 6 hydrogen atoms times the atomic mass of 1. 6 times 12 is 72 plus 6, that's 78. So there's 78 grams of benzene for every mole of benzene. So now our next step is to convert moles of benzene to moles of water using the molar ratio. So the ratio is 2 to 6. So for every 6 moles of water that's produced in a reaction, 2 moles of benzene reacts. So grams of benzene cancels and moles of benzene cancel. So now let's convert moles of water into grams of water. So what's the molar mass of water? So we have 2 hydrogen atoms plus an oxygen atom. 2 plus 16 is 18. So the molar mass is 18 grams of water per 1 mole. So now let's do the math. 50 divided by 78 times 6 divided by 2 times 18. You should get 34.6 grams. So I'm going to put this number over here. So if all of the 50 grams of benzene reacts, 34.6 grams of water will be produced. Let's do the same thing for oxygen. Let's see how many grams of water can be produced if all of the 160 grams of oxygen reacts. So let's start with 160 grams of O2. Now the molar mass for O2 is about 32. It's 16 times 2. So there's 32 grams of O2 per 1 mole of O2. Now at this point we need to use the molar ratio to convert from O2 to water. So it's 15 to 6. So for every 15 moles of O2 that reacts, 6 moles of water are produced. The last part is going to be the same. The molar mass is still 18 grams. So just like before, grams of O2 cancel, moles of O2 will cancel as well, and moles of water. So it's going to be 160 divided by 32 times 6 divided by 15 times 18. So you should get 36 grams of water. So notice that benzene produces a lower amount of product. So 34.6 is the theoretical yield, which means benzene is the limiting reactant. And O2 is the excess reactant. Now that we have the theoretical yield, which is 34.6 grams of water, we can calculate the percent yield. The percent yield is the actual yield of 30 grams, which is that number, divided by the theoretical yield of 34.6 grams times 100%. So you should get a percent yield of 86.7%. So now we could focus on the second part of the question, and that's calculating the amount of excess reactant that's left over. So remember, to find the amount of excess reaction left over, we need to take the total, which is the 160 grams of O2, since O2 is the excess reactant, and we need to subtract it by the amount that reacts, and that's going to equal the amount that is left over. So let's find out how much O2 actually reacts or is consumed in the reaction. What we need to do is start with the grams of the limiting reactant and convert it to the grams of the excess reactant. That's going to tell us how much of the excess reactant reacts with all of the limiting reactant. So let's start with 50 grams of benzene, C6H6. And let's convert it to the grams of O2. So the molar mass of benzene is still 78 grams per 1 mole. So now at this point we need to use the molar ratio between the limiting reactant and the excess reactant. It's 2 to 15. So for every 2 moles of benzene that reacts, 15 moles of O2 reacts with it. And now we need to convert moles of O2 back to grams. And we know that the molar mass is 16 times 2, or 32. So 50 divided by 78 times 15 divided by 2 times 32 is about 153.8 grams of O2. So this is the amount that actually reacts in a reaction. That's how much is consumed. Now, we have 160 to begin with. So how much is left over? So 160 minus 153.8, that's about 6.2 grams. So 6.2 grams of the excess reactant is left over. So that is it for this video. Thanks for watching and have a great day.